Okay, so chapter 4 will be discussing about describing the relationship between two variables. So in chapter 3, we're talking about only one variable and how you describe the one data set. Chapter 4 is focusing on comparing two variables. So first, we'll actually start with when those two variables are quantitative, so numeric values. So when you have two numeric variables, how you can describe the relationship. So the first subsection will be scatter plot, scatter diagrams, and correlation. We'll introduce then least square regression. And then as a part of the least square regression, the coefficient of determination will be discussed. And then 4.4, we'll probably not going to spend too much time, but 4.4 is actually when your two variables are categorical. Okay, so it's first three sections are a little bit different from 4.4 because 4.4 is dealing with a different kind of variable. So 4.1, to start with it, we're going to actually use this example quite a bit, whether shoe size and height are related. It's actually just shows those two variables are the ones that you can easily find from our class survey data. And obviously we can play with other variables as well. But for now, we're going to actually start with the shoe size and height. In general, we have some idea that taller people has a bigger foot, but is that actually true? Can we actually show it has a relationship? Are they positively related, which means the bigger people have tend to have a bigger shoes, or negatively related? The taller people have a smaller shoe size, or they're not related at all. So there are some possibilities, and then using data set, we want to kind of figure it out what's going on there. And then if they're related, are they really tightly related, strongly related, or they're loosely related? Is probably another question that we can answer. So before we actually move on, when you have these type of question, the very first thing is probably what you want to do is draw a scatter plot. So scatter plot is nothing more than, so you have this two plane, and x and one variable, so like say height here, and shoe size, and then your scatter plot, how the scatter plot will look like, right? So we'll start from there. If it is looking like that, you will say, hey, it has a relatively positively related, which means your most of your data set has in this area, right? And then it has it tend to the taller people will have a bigger shoe size. Sometimes you might have this kind of shape, which means probably negative relationship. You might have totally random scatter like that. And for that case, it's probably the x-axis, so height and size are probably not really related. So the very first thing will be probably scatter plot. And then you can think about other measures. The correlation coefficient is one measure that will tell us the direction, one thing, how they're positively related or negatively related, or they're tight or they're loosely related. So we're going to talk about that. As a notation, we use R, the little small r, and it's a measure of linear relationship. By definition, R will be always between -1 and 1. There's a formula, and if you look at the textbook, it actually make you calculate this by hand. We're not going to actually do it by hand. You can also use Google Sheet to go through all this formula and calculate it. We can do that, but for this class, I'm actually gonna skip all that formula thing. I'm just gonna jump into the StatCrunch. And if you run StatCrunch, it will actually spit out your R value directly. So we'll probably focus on how we're gonna interpret that value rather than calculation. So that's what we're gonna do. But even though we are not really calculating this by hand, looking at the formula typically actually helps us to understand what this measure is actually telling us. So there are a few scenario graphs that we have at the bottom of this slide. You see that there is your two variables are perfectly positively correlated. So it has a perfect relationship here, right? And then positively related. So it has all the dots, all the data sets are in that line. This guy, I mean, we just talked about that in the previous slide. It's just random scatter. So your two variables are probably not really related or no correlation, we also say. If you look at this guy, it is perfect negative correlation, right? So when you have no correlation, we'll actually see what happened to our correlation formula. So your correlation formula on top of a numerator, it has a x minus x bar times y minus y bar, right? And in a way, if you look at it this way, this is the z-score, and this is another z-score, and you're kind of multiplying it. But let's look at actually this way. Let me. Okay. So let's look at this way, this guy. So here are your x's, and your x bar is probably somewhere around here, right? X bar is probably right here. Y bar is in the middle of y, so y bar is right here. Okay. If you think about this measure, which is you multiply x minus x bar and y minus y bar and add a whole bunch of them. If you're looking at the data set in this side, your x minus x bar will be positive value because your x values are bigger than x bar, positive value. And y minus y bar, so this is the y value and the y bar value is here, so it will be plus. So when you're this side, you're multiplying those two values will be all plus. When you're this side, it will be actually minus and minus. Here, minus and minus, right? So minus times minus will be actually plus. If you're in the other side, this area and this area, it's actually the other side, plus minus or minus plus. So if you multiply those two, you're actually gonna have minuses if you actually multiply it. So if you look at this four different side, you're gonna have, once you multiply, there are a whole bunch of positive values here and here, whole bunch of negative values here and here. If you add a whole bunch of positive values and a whole bunch of negative values, what's gonna happen is you're gonna have like a zero, right? And if you add all those up, it will be actually close to zero. So for this case, your R will be actually very close to zero. When you have a perfect positive, here we are, your data set is mostly this side and this side, right? Which means if you multiply those two values, you will always have positive values. So, and then you scale it with the Sx and Sy and n minus 1. So what's going to happen to your R is actually close to 1. So when you see R is equal to 1, that means it is perfectly positively related. On the other end, this one, most of your data set is here and here, which is right there, right? So all your multiplication values will be actually minus. So if you add all a whole bunch of negative values, you will still have a negative value. So this case, your R will be -1. Okay, and everything else is in the in between. Okay, so the how fit it is, so how close your data set to the line, the trend, is slightly less intuitive compared to the direction. So we'll probably revisit that later in 4.3. But want to point out that um, the difference between these three are when all three of them have a positive relationship between two variables. The first one is more perfect relationship. Second one, we call the strong relationship because most of the data set is in that trend. The third one is a little bit more spread out, right? It still has a some positive relationship, but it's more spread out. So that one, we call that weak positive correlation. Same way, these three also has the same direction, negative relationship. This one is a strong negative relationship because all the data points are close to that trend line. And this guy is a little loosely fitting your line. So this guy will be, I mean, I don't have an exact number because this is just illustration, but this will be somewhere like 0.8, 0.9-ish of values you will see. The third one, you will see probably 0.4, 0.5-ish numbers. The other way, this guy will be maybe around -0.4, -0.5-ish number. And this guy will be -0.9 or -0.8-ish number that you're gonna see it. Okay. And now let's go back to our StatCrunch and try to get the R value and how we're going to interpret that value. So I will go back to our stat key. Here we are. That's not what I want. Sorry about that. Here is my data set, right? Okay, my class survey data set. Again, the first thing I want to do is we're talking about shoe size and height. So I will draw a scatter plot. So if you go scatter plot and you just decide which one goes X and which one goes Y, I'm going to put the height as X and shoe size as Y. And then I'm going to click compute. And here is your scatter plot. Ooh, that looks weird. What's going on? Well, there's most of the data set here. There's one weird looking data set. It's probably outlier, right? It lies outside of its range. Whenever you see the outlier in the data set, you don't necessarily delete it right away. The outlier means you need a special love and see what's actually going on. For this particular value, it is the value that shoe size over 100. Is that possible? Maybe, maybe not. But in the American shoe size, it's probably not possible to be 100. There are a couple scenarios when you see outlier. It might be just a value that is really weird. So it's a still meaningful value. Or it can be a typo, or it can be using some other measure. For example, I mean, if it's my class survey I collected from my own classes, there are a couple semesters I have a couple weird values consistently, especially in terms of shoe size. Later, I learned that there are actually the exchange students from France. So they were using different scale of shoes. So, you know, I was able to kind of transform to back to American shoe size and, you know, still use the data set. For this particular case, though, it is over 100. if it is European size, it's like a 30 some, 40 some, or something like that. But this is way weird. So I actually looked at this data set before. And if you actually go very at the bottom, there is this 113 point. So it might be just typo, or somebody, when you type it in, you might just forget the decimal point between 11 and 3. I mean, obviously there is no 0.3 size, so it might be just 11. It's kind of hard to see what's going on, right? But so depending on what you found, this value will be different. But for this particular case, I think it is actually 11. So I'm just going to actually use 11 for this data set. Okay, then I'm going to draw it again. Okay, so scatter plot one more time, and height and shoe size, compute. And now it looked like that. So just looking at scatter plot, does it look like how can we describe the relationship between height and shoe size? It looks like a little positive thing going on. And it's probably not really super tight because there are a lot of variation going on there. So I don't know, my expectation, my guess prediction is R is probably 0.5-ish, maybe 0.4-ish, something like that. Let's see. So here's your stat, and under stat, there is where's a correlation? Maybe somewhere is, there we are. Somewhere is stat and correlation there. And you're just gonna shoe size, and I guess you can shade at the same time, and then compute. Here we are, my correlation is 0.6067, is 0.6066. So how would you describe that relationship? So you're gonna have R is about 0.6066. So you will probably say something like moderate positive relationship. So you can say that. Just for fun, I add a couple more examples here you can play with. So calorie intake versus water drinking, because there are those variables in your StatCrunch as well, and weight and sleeping hours. Okay, so you do the same thing and find out what's the R and think about how you would interpret their values. Yeah, I will actually leave it up to you. And this is the end of 4.1.